Alright guys, so now we got lesson 4-6. It's called Formalizing Relations and Functions. So we have two objectives here. The first one is determine whether a relation is a function. And then the second one, and then this is new vocabulary, is going to be find domain and range and then use function notation. So this lesson, it's pretty straightforward, but it does have a lot of vocabulary. So make sure you copy down all of the vocabulary and then try and learn it so that we can start using it in class, because the vocabulary that we do here we'll use throughout the whole rest of the year, so it's really important. Okay, so the first part we have, we've talked about relations before, but here's a definition. It's a pairing of numbers in one set called the domain with numbers in another set called the range. And oftentimes these are just a set of ordered pairs. So like an example, they usually just have squiggly brackets, so 1, 2, and 3, 4, and 5, 6. That could be a relation. Okay, anytime you have ordered pairs, any set of ordered pairs, that's a relation. So the domain would be the x values. So the domain in this little example would be 1, 3, and 5. And then the range would be the y values. So the range is 2, 4, and 6. So you could see that you could graph those ordered pairs, and that's eventually what we're going to start doing, is graphing them. And that's why a relation is a pairing of numbers. So 1 goes with 2, 3 goes with 4, and 5 goes with 6. So every time you have a domain value, it gets matched with something in the range, and that's where we get the ordered pairs, and that's how we can plot points on the coordinate plane. Okay, so one thing here to be able to tell, so it says identify the domain and range of each relation, represent the relation with a mapping diagram, and then we have to tell if the relation is a function. And remember, if it's a function, you have to have exactly one input for every output. And if it was a function, you can't have repeats in the x values. So now, we can't have repeats in the domain. So, let's see. I usually just, in the squiggly brackets outside these, those are just mean because you have parentheses inside. They don't really mean anything. So, I usually put D, and I identify the domain. So those are all the x values. They should go in order from least to greatest. So a lot of times they're written like that, but sometimes they're not. So the domain would be -2, 0, 4, and 5. All the x values. The range is all the y values. And they're not quite in order, so we're going to flip those around. We're going to have 0.5, 2.5. Now if you have another 2.5, it's just the set of numbers, so you don't need to write all the numbers, you just need to write all the different numbers. So I'm not going to write 2.5 again, and then I'm going to put 6.5. Okay, so when you do domain and range, try and put them in order from least to greatest, and then if you have repeats, you don't need to put the repeated numbers. Okay, now here's what the mapping diagram looks like. It's kind of like you're going to have a big bubble for the domain, and you're going to have a big bubble for the range. Okay, once you identify the domain and range, you put those numbers in each bubble. So -2, 0, 4, and 5 for the domain, and then 0.5, 2.5, and 6.5 for the range. Then you need to go back to your actual relation, and I'll see if I can erase some of this. And you need to map the numbers that go with based on the ordered pairs. So -2 maps with 0.5 from the first ordered pair. So you just draw a line from -2, whoops, go back. Draw a line straight from -2 with an arrow to 0.5. Those two map together. Okay, and then we have the second ordered pair maps 0 to 2.5. So from 0, you draw that to 2.5. Then we have this one, 4 maps to 6.5. And we have 5 maps to 2.5. Okay, so the last part here is the relation a function? Well, from a mapping diagram, from a set of ordered pairs, you're looking to see if any x values repeated. And if you just look at the x values, you look at the domain, nothing repeated. There was a repeat in the range, but that's okay. Y values are allowed to repeat. So is the relation a function? We're going to say yes. Okay, from a mapping diagram, how you're going to be able to tell, and I think the next example happens, but let's just say you had two lines coming out of the same domain. That would mean that you had a repeat in the domain, and it would make it not a function. So if you ever have a question of how can you explain that a relation is a function from a mapping diagram, you can just say if there's two lines coming out of the same domain number, it would have repeated x values, which would make it not a function. Okay, so that's a mapping diagram. Let's do one more mapping diagram. So let's identify the domain. That's the x values. So let's see, I have 4, 6. So in order from least to greatest, I have 4, 5, and 6. Now, do you see how the 6 was repeated? So I have a 6 here and I have a 6 here. So automatically it's not a function. Anything can be a relation. Any set of ordered pairs is a relation, but in order to be a function, it can't have repeats in the domain. Okay, then we have our range. Looks like we have 3, 4, 5, and 8. Okay, that's domain and range. Then we make our mapping diagram. We're going to put 4, 5, and 6 in the domain, 3, 4, 5, and 8 in the range. And we're going to go back to the original set of ordered pairs, and we're going to map 6 with 5. And then we're going to map 4 with 3, 6 with 4, and 5 with 8. Okay, so you could also tell here there's two numbers coming out of the 6. So again, that's what makes it it's always a relation, but it's not a function because this right here, you have an x value that showed up twice, and every x value is only allowed to be paired with one y value. Okay, next vocabulary we have here, it's called the vertical line test. So if any vertical line, and remember, vertical lines, those go up and down like this, passes through more than one point of the graph, then some domain value is related to more than one range value, and the relation is not a function. So think about a coordinate plane. Okay, these are your x values going like this. So you have x values all over the place. If you are to draw a vertical line and it hits more than one value at a time, it's going to hit more than one x value, right? If I have this ordered pair and I have this ordered pair and I draw that red vertical line, then it hit the same x value more than once. So if that happens, you say it failed the vertical line test and it makes it not a function. Okay, so any vertical line that passes through more than one point of a graph, it can pass through at least two, but 3, 4, it doesn't really matter at that point. As long as it passes through more than one, then the relation is no longer a function. Okay, so I took this right out of the book. It says, is the relation a function? Use the vertical line test. So in part A, they took these ordered pairs, 1, 2, 3, 4, 5. They took these 5 ordered pairs and they plotted them. Those are the red dots. Then they took these black lines and they drew straight up and down. See how this black line hits that dot and that dot? So right there, it fails the vertical line test, which makes the relation not a function. That dot is okay because there's only one line. That's okay, and that's okay. So it fails the vertical line test, so it's not a function. Over here, they just gave you an equation, and we could make a table and we could graph that, but no matter where you draw these vertical lines, you're never going to hit more than 2 points. Now, so this is a function. What confuses people is they try and draw horizontal lines. If I were to draw a horizontal line, it would hit right there and right there. But you're allowed to have repeats in the range, which is your y values. So there is no horizontal line test. It's only a vertical line test because it's only the x values that can't repeat. Okay, so that we use the vertical line test when we have graphs to prove if a relation is a relation is a function or not. If it hits more than 2 points, it's not a function. Okay, and last part of vocabulary, it's called function notation. This seems to give everybody trouble, but just don't overthink it. It's not quite as complicated as you think. So it's used to emphasize that a function value, which they're calling, how you read this, you read this f of x. So it's used to emphasize that the function f of x depends on the independent variable x, because the independent variable is always on the x-axis, and then this function right here would be the dependent variable. So it depends on the independent variables. Other letters other than this is supposed to say f can be used. A lot of times they use f because it's function notation, but you can use g and you can use h. Those are the most common ones I've seen. So all they're taking here is, say you have a regular equation. Y equals negative 3x plus 1. Y would be, the y-axis is the dependent variable, and the x-axis is the independent variable. So all they're doing is taking the y and they're replacing it with f of x. Everything else stays exactly the same. So if you have an x, this is just saying that this is a function of whatever x value you plug in. So if I want to make it a function of 5, I just do negative 3. So they would say f of 5. We would plug it in like that. That doesn't mean you're taking f times 5. You're not really doing anything there. That just means that you're plugging in 5 for the x value, and then you plug it in for this x value, and then you just evaluate it. So f of 5 is equal to negative 15 plus 1 would be negative 14. Okay, so f of 5 is equal to negative 14, which means your x value is 5, and your y value is negative 14, because whatever you get when you substitute in for f of x is your y value. Okay, I know that was kind of a lot, but we'll do more to practice those. Okay, so here's a function. The function w of x equals 250x represents the number of words wx. Okay, so that's our dependent variable, the number of words you can read in x minutes. And time would be the independent variable. So how many words can you read in 8 minutes? So we want to do a function. We're going to do 8 minutes. So the function in terms of 8 minutes, so we write W8 equals 250, and then we just multiply by 8. So 250 times 8 is equal to 2,000. Okay, so all that means is if you were to graph this, well, we don't have to graph it, but if you're going to graph it, the x value is 8, and the y value is 2,000. 2,000 words, right? Represents the number of words, yeah. 2,000 words. All it is an equation, and people get most confused right here because they think they're trying to take w times 8, and they need to know what w is, but it's really just showing you that the x value you're plugging in right here is 8 is the same x value you're plugging into the equation. That's all it is. Okay, so here's another equation written in function notation. It says the domain of this function, g of x, so we got 4x minus 12 is 1357. Okay, that's the domain. You need to find the range. So we need to find g of 1. Okay, we're going to plug in our first domain value. Is going to be 4 times 1 minus 12. Okay, 4 times 1 is 4. 4 minus 12 is negative 8. And then we need to find g of 3. So the function evaluated when the x value is 3 is going to be 4 times 3 minus 12. And 12 minus 12 equals 0. Then we need to find g of 5. So 4 times 5 minus 12. 20 minus 12 is 8. And then we need to find g of 7, which is 4 times 7 minus 12. 4 times 7 is 28. Minus 12 is 16. Okay, so what is the range? Notice how they put the domain in brackets like that because it's a set of numbers. So the range we're just going to put in a set of numbers is going to be these numbers right here. So negative 8, 0, 8, and 16. Okay, so you use the function notation. It gives you the domain. Remember, those are your x values. You plug them in for x right here into the function. You evaluate the function and you get a set of y values. Okay, take a look at the lesson check on page 271. A couple problems have to do with domain and range, a couple have to do with vertical line test, and then a couple have to do with function notation.